Hello, everyone. This is going to be our last class. I'm going to do one more example from section 3.4. Last time we were talking about linear programming. So I'm going to go through one more example, talk about a couple different things as far as what can happen, what you should be looking for, and how you can answer the questions. All right. So again, we're going to be graphing a system of inequalities. So again, a system means, two or more. So we've done two inequalities. We've done three inequalities. In the homework, there was one that had four inequalities. So you can have any number of inequalities. The process is still the same. You graph each inequality one at a time. All right. And then once you have them all graphed, I guess the hard part would be trying to figure out what we call the feasible region, which would be the part that was shaded when you looked at all the lines. All right. As I explained in the last video, I kind of always keep the shading till the very last part. Otherwise, if you start shading all over, you can't even figure out where your X and Y axes are or anything like that. I also have a little trick that I'll show you today that might help as far as like what you're looking for as far as that feasible region. All right. So for this problem, we do have four inequalities. You can see them on the bottom here. So we have y greater than or equal to 1, y less than or equal to 7, x greater than or equal to -2, and then we have y less than or equal to -2/3 plus 7. All right. Now again, it looks like a lot of lines. However, these three right here, so this one only has the x, this one only has the x, I'm sorry, the y. My bad, these two only have the y, this one only has the x. So what that means is these are going to be either my horizontal or vertical lines. Okay. This last one here, you can see has both the x and y. So again, that's in my slope-intercept form. Okay, so if you notice it only has the one variable, again, you should automatically be thinking, okay, horizontal or vertical. Those are usually pretty quick ones to graph. All right, so let's go ahead and let's start with this one. It says y is greater than or equal to 1. So we go to the y-axis. I'm going to put my point at 1. And again, this is going to be a horizontal line. Okay, so if it says y, you should have a horizontal line. Okay, so I've got my nice horizontal line like that. All right, and again, let's not worry about the shading yet. My second line that I have says y is less than or equal to 7. So again, that's going to be another horizontal line, this time though through 7. 1, 2, 3, 4, 5, 6, 7. So again, I'm going to put my point on 7, and I'm going to draw my nice horizontal line. All right. Okay, so those two are done. The third one, we have x. So again, this time, this is going to be a vertical line. It says x greater than -2. So on the x, we're going to go to -2. And this time we draw a vertical line. All right, looks something like that. All right, so again, the verticals and horizontals usually pretty quick. Just make sure you get them going in the right direction. Okay, my last one here, this is again already in slope-intercept form, so we're pretty much ready to go. My y-intercept is a 7, so I'm going to count myself up to 7. 1, 2, 3, 4, 5, 6, 7. Okay, which would be right there. Put my point. My slope is a -2/3. So again, my line should be going downward. I'm going to go down 2, right 3. Down 2, 1, 2, right, 1, 2, 3. All right, I'm going to go down 2, right, 1, 2, 3. I'm going to go down 2, 1, 2, right, 1, 2, 3. All right. And again, when you're making these, you do need to be kind of accurate because again, in a minute, we're going to be looking for, again, that shaded section, and I want some nice straight lines here so I can tell what I'm looking at. All right. So now we have all of our lines. All 4 lines are in our graph. Now I need to figure out where's this shaded section. It's called the feasible region. So what would I shade if I kind of put all of these together? Okay. So sometimes what I like to do is grab myself some little pieces of paper here, and one at a time, I'm going to kind of lay down my paper to kind of narrow down my graph. All right, so for example, if we go to this one here, the first one says y greater than or equal to 1. Okay, so this line right here, the green one, was my 1. Greater than means I needed to be above. Okay, so I'm going to kind of line my little paper up here. I needed to shade above, which would be going this way. Okay, so I can't cross below my little strip of paper. My second line says y is less than or equal to 7. So again, that's my other green line that we have on here. Less than means it needs to be below. Okay, so I'm going to take another strip of paper and I'm going to put it like that. So what that means is I'm kind of narrowing down my graph. I know right now, just with those two, I have to stay between these pieces of paper. All right. My third line, we've got x greater than or equal to -2. So that's in my case, I did this in color. That's my orange one. Greater than, okay, so if this is my orange one, I need greater than means I need to go this way. All right, so again, I'm going to cover up this section over here because I can't go that way. I have to stay this way. All right, and then my last one, here's my purple line. We need to be below the purple line. So again, I'm going to take my piece of paper, I'm going to line it up. I need to be below my purple line, okay? So now, by laying down my little strips here, you can kind of see this section in the middle here, in between, is what we'd call the feasible region, okay? And what you're looking for is you're looking for the vertices or the corners of that feasible region, all right? So since I have my little papers down here, what I'm going to do is I'm going to go to each corner. I'm going to kind of put a big black dot there, black dot there, there, and then, oops, right over here. All right, so now what I'm gonna do, I'm gonna take my little strips of paper off here for a second. Okay, and if what we were looking for, again, the shaded section would end up being everything in this part right here. Okay, on your homework, some of the feasible regions were triangles. On one of the homework questions from last time, it ended up being like a rectangle. So again, the feasible region or that shaded section can be any shape. It just kind of depends upon what kind of lines you have and where they were going. So in this particular case, this is a trapezoid, if you know that or not, but it kind of looks like this. Goes across the top, goes across the bottom like that. We got our orange line here, kind of making this side of it. Okay, and then we got our purple line here, making the other side. So this is our feasible region. Okay, these four corners, okay, are the vertices of our feasible region, and those are important because the next thing that we're going to do is we're going to talk about, like, how do you find a maximum or minimum? Okay, so again, a lot of times maximum, you want to find the biggest value. Minimum, you would find the smallest value. All right, and this comes into play a lot of times with businesses. You want to maximize your profits, you want to minimize your costs. Okay, so let's go ahead and on my graph here, let's write the ordered pairs of my vertices. Okay, so this one here, we have -2, 1. Okay, so -2, 1. This one up top there will be -2, 1, 2, 3, 4, 5, 6, 7. -2, 7. This one right here would be 0, 7. In this corner here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. Okay, so those are the vertices of my shaded region. All right, so now the last step is, how do you go ahead and find that maximum or minimum value? And again, it would depend on which one they want, so just kind of pay attention to the question. And what you're going to do is you're going to take those ordered pairs that we just wrote down, and you're going to substitute them into a particular, what they call objective function. All right, I'm going to move my graph out here for a second. All right, so these are the lines that we just graphed. Okay, these are the vertices that we just found from our graph. Okay, again, the vertices, the corners of that feasible, that shaded region. All right, in this particular problem, I am asking you to find what would be the maximum profit. All right, so I'm going to give you a profit function. P is usually the variable they use for profit, and my profit function is 2x plus 4y. All right, so again, in your ordered pairs, the first number stands for x, the second number stands for y, and what you are going to do is one at a time, you take your ordered pairs and you plug them into here. And again, we are looking for, in this case, the maximum number that we end up with. All right, so might want to get your calculator out if you need it. So if I take this one, we have 2 times a negative 2 plus 4 times 7. So 2 times negative 2 plus 4 times 7. So give me a value of 24. All right, let me do the next one. We've got 2 times negative 2 plus 4 times 1. All right, so 2 times negative 2 plus 4 times 1. That would give me a value of 0. Wouldn't make a lot of money there. My third ordered pair, we have 2 times 0 plus 4 times 7. Okay, that would give me 28. And then my last one, we have 2 times 9 plus 4 times 1. So 2 times 9 plus 4 times 1. That would give me 22. All right. So if in this case I'm looking for a maximum profit, all you have to do is take a look at these numbers and choose the one that is the largest. So of these 4, 28 is the biggest number that I came up with. So this would be my maximum profit. My maximum profit would occur at that particular ordered pair that we had in our graph that was 0, 7. All right. So I've got a couple more of those for you to practice again tonight. All right, this will be like your last homework assignment. Next week, you'll be working on what we're going to call the MVP, kind of the final project. All right. So again, it's going to be looking something like we did here. Okay, so you graph, you shade, and you find the vertices of that feasible region. Like I said, it might be a triangle, might be a square, might be a rectangle. In this case, we have a trapezoid. All right. Again, good luck. Let me know if you have any questions. Send me an email and I will answer. Have a good night.